Hey guys, today we're going to learn about properties of water. First off, this is Thomas. Now, as you can see, Thomas is a train. But Thomas is no ordinary train. Thomas is a very, very intelligent train. Thomas is so intelligent, he knows Christmas is only a week away. That's why Thomas set up his Christmas tree. As young Thomas lay down that night to rest, he thought about Santa Claus and his one main gift he wanted for Christmas. Thomas only wanted one thing for Christmas, the power to control water. Why water, you might ask? Well, that's because nobody's played with him in 12 years and, as you can see, he's covered in dust. In order to wash off all this dust, Thomas needs a lot of water. However, despite all Thomas's intelligence, he doesn't know a single thing about water. Now that's a problem. So what exactly is water? Well, according to Google, water is a transparent, tasteless, odorless, and nearly colorless chemical substance, which is the main constituent of Earth's streams, lakes, and oceans, and the fluids of most living organisms. It is vital for all known forms of life, even though it provides no calories or organic nutrients. Contrary to popular belief, water is not wet. According to the Oxford English Dictionary, the most widely accepted English dictionary in the world, wet is described as being covered or saturated with water or another liquid. Now, water is not covered or saturated with water or another liquid. So don't go up to me saying that water is wet, because I know that water is not wet. And Thomas also knows that water is not wet. Aside from being not wet, here are some other physical properties of water. Its boiling point is 100 degrees Celsius or 212 degrees Fahrenheit. Its melting point is 0 degrees Celsius or 32 degrees Fahrenheit. Its molar mass is somewhere around 18.01 grams per mole. Its density is 997 kilograms per meters cubed, and it is also named oxidane by the International Union of Pure and Applied Chemistry. The first step to understanding water in chemistry is to know that water is polar. This means that the electrons are shared unevenly between the atoms in a water molecule. This is because oxygen and hydrogen have a significant difference in their electronegativity values. You should know that oxygen is more electronegative than hydrogen. Therefore, the electrons are more likely to be found around the oxygen side of the water molecule and less likely to be found around the hydrogen side of the water molecule. Due to this, the oxygen side of the water molecule is given a partial negative charge, and the hydrogen side of the water molecule is given a partial positive charge. Because of its polar covalent bonds and its elemental composition, water has the unique ability to form hydrogen bonds. Now, hydrogen bonds are the single most important thing you need to know about water in chemistry. You can literally answer any water question in chemistry by just saying hydrogen bonds and kind of knowing what they are. For example, why does water have a high boiling point? Hydrogen bonds. How do those little tiny bugs in Madagascar walk on water? Hydrogen bonds. Why does Mrs. Nielsen like yoga? Hydrogen bonds. Why does my dad wake up late every Sunday? Hydrogen bonds. Anyway, hydrogen bonds are a powerful intermolecular force that exists between two or more water molecules. In a hydrogen bond, the partial positive hydrogen exhibits attraction to the partial negative oxygen of a different water molecule. Pretty much, hydrogen bonds make water extremely attracted to itself, which gives water many unique chemical properties. First of all, water's got a high boiling point. In order to boil a substance, you need to have sufficient energy to break a certain amount of intermolecular forces. But because hydrogen bonds are significantly stronger than other intermolecular forces, it requires a significantly greater amount of energy to heat up substances with hydrogen bonds, for instance, water. Therefore, because water has strong intermolecular forces, it has a high boiling point. Another unique thing about water is the density of its solid state compared to the density of its liquid state. Ice is less dense than water. This is because ice molecules form structures that allow air pockets to exist, whereas water molecules fit tighter together. For this reason, ice floats on water. Water's attraction to other water molecules due to hydrogen bonds is called cohesion. One example of cohesion is surface tension. Surface tension is a weak barrier at the surface of water that prohibits light objects from breaking through. Because of surface tension, hair and leaves float on water, and certain insects can even walk on water. If water is so attracted to itself because it could form hydrogen bonds with itself, then that must mean that water is just as attracted to other substances it can form hydrogen bonds with. This is called adhesion. An example of adhesion is capillary action. In capillary action, water molecules travel up a tube against the flow of gravity because of their attraction to the molecules in a tube. Water is known as the universal solvent because, due to its polarity and hydrogen bonds, water dissolves more substances than any other liquid. Whereas many solvents can only dissolve a few select things, water has solubility rules that describe a numerous amount of possible solutes. Compared to other substances, water is considered viscous. Viscosity is the ability a liquid has to resist flow. Viscosity can also be thought of as thickness. Viscosity exists on a spectrum, it's not black or white. One of the least viscous substances is helium liquid. That's not thick. Ketchup, on the other hand, is pretty thick. It's really viscous. In other words, it resists flow. The most viscous substance known to mankind is displayed in the pitch drop experiment. This substance is so viscous that it only forms a single drop every several years. In other words, it's dummy thick, as in you would be a dummy to call it not thick. This guy knows. Lastly, water has a really high specific heat. Specific heat is the amount of heat energy required to raise the temperature of 1 gram of a substance by 1 degree Celsius. In order to raise the temperature of water, you need to break a lot of hydrogen bonds, which requires a lot of heat energy because hydrogen bonds are strong. Therefore, water has a high specific heat. Hope you guys learned a lot about water and its properties today. Thanks for watching.